Today we're going to talk about the chemical properties of alkanes. So we're going to mention the reactions that the alkanes are able to carry out. But before talking about this, we need to know that the bonds that are found between the carbon atoms inside the alkane structure are actually very strong sigma bonds. And these sigma bonds are very hard to be broken. So accordingly, the alkanes are considered relatively inert if compared to alkenes or alkynes, considering the abilities of chemically reacting. So, in other words, the reactions that the alkanes are able to carry out are very few if compared to the other types of hydrocarbons. So, the first type of reaction is combustion, or burning. And the concept here is very simple. So if we have, for example, methane, and it reacts with 2 moles of oxygen in the presence of heat, we will get carbon dioxide gas plus 2 moles of water plus heat. So we conclude from that this reaction is an exothermic reaction because it produced heat as a form of energy. So that's why the alkanes are actually used as fuels, because they generate heat when they are burned. So this is the first type of reaction that we have today. The second type of reaction is the reaction with halogens. The reactions with halogens, and by halogens we mean fluorine, chlorine, bromine, and iodine. And this reaction has 2 conditions. Whether it happens in the presence of direct light, and in this case the reaction goes as follows. We have the methane molecule, and it will react with 2 moles of chlorine gas like this, and in just one step we will get 1 carbon atom plus 4 moles of hydrochloric acid. And what happened here is that the 4 atoms of chlorine gas that we have here took all the hydrogens in one step, or in other words, they eliminated them from the methane to produce this acid. So they eliminated them from methane, and this is why this reaction is called elimination reaction. So this is an elimination reaction. On the other hand, if this reaction occurred in the presence of an indirect light, so we will have an indirect light, it's totally the opposite, because the reaction will be a substitution reaction. So we understand from this that the hydrogen atoms, instead of being eliminated, all of them, in just one step, they will be substituted by other atoms. We'll see. So we have the methane like this. And instead of reacting with 2 moles of chlorine, it will just react with 1 mole. And of course here the condition on the atom will be indirect light. And what will happen is that 1 hydrogen atom will substitute 1 chlorine atom here, and 1 chlorine atom will substitute 1 hydrogen atom. So we will have CH3Cl plus HCl instead of having ClCl, which is Cl2, and CH3H, which is CH4. So this is why it's called substitution. And we will have monochloromethane. We will take this and repeat the same reaction again, because there is an ability to repeat the substitution process, because we still have 3 hydrogen atoms here. And we'll find out that the same thing that happened here will happen here again, and we'll have CH2Cl2 plus HCl. Dichloromethane. Again, we still have two hydrogens, so CH2Cl2 reacts, well, Cl2 in the presence of indirect light, and we will have CHCl3 plus HCl. This is trichloromethane, or chloroform, which was used as an anesthetic before, but it caused lots of mortalities because it was very hard to detect the suitable dose for the patients, and it was dangerous, so they banned this chloroform to be used as anesthetic. So the final hydrogen will have CHCl3 plus Cl2. Again, in the presence of indirect light, we will have trichloro or tetrachloromethane or carbon tetrachloride, because we just have carbon here. We can say that this is called carbon tetrachloride or tetrachloromethane. And obviously, this reaction is carried out in 4 steps, as we can see, because in the initial step we had 4 hydrogens. So in order to substitute all of them, we'll have 4 steps, as we can see. So this is the substitution reaction that the alkanes carry out with halogens. The last reaction that we have is the thermal catalytic cracking. So, thermal catalytic cracking. So this reaction will be done in the presence of a very high temperature, in the presence of a catalyst, in order to crack down the alkanes. So if we have long chain alkanes, for example octane, which is C8H18, octane, and we apply this reaction, so heat and pressure, actually there should be pressure and a catalyst, we will get something like this. This alkane will be cracked into C4H8 and C4H10. So the alkane will give us an alkene, which is your butene in this case, and another alkane, which is butane. So the alkanes resulting from this reaction can be used in the fuel industry, like butane, and the alkenes can be used in polymerization to form polymers. So short chains together, they can form larger chains or larger complexes, which are called polymers, and these polymers can be used in plastic industries and so on. So that was the third reaction that the alkanes are able to carry out. In fact, this is everything that we have today, and so the next time we are going to talk about the economic importance of alkanes and their halogen derivatives. So until the next time, I thank you for watching and see you.